Look at basically backwards what we have been doing. We've been graphing equations. Here we're going to take our graph and make an equation from it. So to start our day, I have what's basically a brief summary page here of each of our functions. We're going to list our 5 critical points along with our maximum values here. So our sine curve starts here at 0 on the x-axis, has a quarter point at pi over 2, a midpoint at pi, a 3/4 point at 3 pi over 2, and it ends at 2 pi. It goes up to 1 and it goes down to -1. Quick summary of our sine curve with its generic critical points along with maximum and minimum values. So cosine also starts over here at 0 on the x-axis, has a quarter point down to the x-axis at pi over 2, a midpoint at its lowest point at pi, 3/4 point back up to the x-axis at 3 pi over 2, and the end of 1 period at 2 pi. Cosine also goes up to 1 and down to -1. For both of those, I'm going to write here at the top, the period length is also found by taking 2 pi and dividing it by b. So I'm going to try and fix that a little bit. Okay, so 2 pi divided by b. Our tangent, our cotangent are pictured down here at the bottom. Our tangent has a left asymptote line at -pi over 2, a quarter point at -pi over 4 and -1, a midpoint at the origin, 0, 0, a 3/4 point at pi over 4 and a +1, and it has a right asymptote line at pi over 2. Those are our 5 critical points. Amplitude is defined by this quarter and 3/4 points being at 1 and -1. That's basically the only real change you'll see in the amplitude with tangent. If this were pi over 4 and 3, then our amplitude is 3. If this were pi over 4 and 1/2, our amplitude is 1/2, and so forth. So that's the one area that the amplitude will be most noticeable on. Over here we have a cotangent curve. We have a left asymptote line at x equals 0, a quarter point at pi over 4 and 1. Our midpoint goes through at pi over 2 and 0. Our 3/4 point goes at 3 pi over 4 and -1. And we have a right asymptote line here at pi, or x equals pi on the x-axis. So our critical points, noting that these graphs continue to move up and down, getting closer and closer to the asymptote lines, but never touching or crossing. So there's our tangent and cotangent. Get rid of that random line. Period length for tangent and cotangent is pi divided by b. So a quick summary page. We've got all 4 of these graphs already in our notes. We need to know these critical points and the shapes of the graphs inside out as we move forward, because we'll use those to find our period length, or the length of a period, in addition to finding the shifting, the horizontal translation, so to speak, our C value that will make this equation happen. Let's just move on then. We have a picture here. Maybe I better make that smaller after all. Find the graph or the function that will produce the graph below. So the only point I have labeled here is pi over 3. Notice that's also the lowest point on our curve. I'm also going to be able to label this one. This one comes from the origin at 0, 0. So the first thing we have to decide is, what are we working with, a sine or a cosine curve? And honestly, it could be either one. So we'll start with a cosine curve. When I say cosine curve, we're going to find y equals a times the cosine of bx plus c, knocking off one of these variables one at a time, a, b, and c. Amplitude is our a value, so notice this graph goes up to 3 and down to -3. So very simply stated, our amplitude is 3. Now, to find our period length, or our b value, to find b value, we actually have to find our period length for this function first. Then we have to convert it to a full period length and then use it to find where our b is. So to find the period length of this particular graph, I'm going to find the distance between 2 points on the x-axis. The only 2 critical points I know are those 2 that we have labeled, pi over 3 and 0. So pi over 3 minus 0 is pi over 3. The distance from here to here is pi over 3 units. Now if we think generically about the cotangent or the cosine curve looks something like this. So we've just found the distance between this point right here and this point right here in a generic sense, where the lowest point is right here and the crossing the x-axis right here. So you'll hopefully notice that's a quarter of a period. So I'm down here, I'm going to say 1/4 of a period equals that distance of pi over 3. I want to solve for a full period length, so I'm going to multiply both sides by 4. That way I get p by itself, and my period length equals 4 pi over 3. Now, generically speaking, the equation we've been working with for several days now is period length equals 2 pi divided by b. Notice that both of those distances or amounts are set equal to a period length, so they're equal to each other. 4 pi over 3 equals 2 pi over b. By simple substitution, we'll cross multiply to solve. 4 pi times b equals 6 pi. And when I say cross multiply, I went here and here. So 4 pi times b and 2 pi times 3. And I'll divide by 4 pi. And b will equal 6/4 or 3/2. Oops. So b equals, the pi's will cancel, 6/4, and 6/4 simplifies to be 3/2. So we've progressed now here where we have our b value equal to 3/2. So notice we're 2/3 of the way done. Now to find c, we're going to take our argument. I'll just pull it off to the side here. So my argument is the 3x plus, or 3/2 x plus c. I left a blank. Oops, I don't need that equals 0 there. I left a blank where the x is because I'm going to make a substitution of either one of these x values up here into my equation so I can solve for c. So in this case, 0 is an easy number to work with. Here's an x value that's on my graph, so I'm going to put 0 in here. Now I'm going to scroll back up just a little bit. That point is where my graph is coming down through the x-axis. So back up here on my generic curve, sine comes down through the x-axis at pi over 2. Okay, so you can see that coming down through. That's our critical point. I'll actually go back to the previous page to illustrate that. Here's where we're coming down through the x-axis. Notice how it occurs at pi over 2. So that's what I set my argument equal to. 0 makes this work easy because 3/2 times 0 is 0. 0 plus c is c. So c equals pi over 2. Or ending up y equals 3 times the cosine of 3/2 x plus pi over 2. There's my equation of a cosine curve that fits that graph. Now with that being said, we can find a second function. That graph, I think you would also agree, could also be a sine curve. I'm going to start from scratch. Y equals a times the sine of bx plus c. Before we moan and groan too much, there's good news here. Sine and cosine have the same amplitude and the same period length, so our a and b are the same. So y equals 3 times the sine of 3/2 x plus c. C value is going to be different because the shape of the graphs is different. The high and low occur at different places. But I can set up the same argument, 3/2 times 0, I'm going to put this x value in there, plus c equals, now again this point's coming down through the x-axis, so I'm going to go back here, sine is coming down through the x-axis at pi. So notice right here is where we're coming down through the x-axis. This point's coming up through the x-axis, as is this one, so it's not the mirror image. We want it down through the x-axis. That occurs at pi, which means I set my argument equal to pi. And because 3/2 times 0 is 0, c equals pi. So my equation for a sine function is 3 times the sine of 3/2 x plus pi. And there we have two functions for the same graph. Let's go ahead and move on to our next one here. You can see we have a completely different shaped graph. I'm going to hope or assume that we would all agree that this is probably a tangent function to begin with. So I'll write the generic sense of it right here. Amplitude, mentioned this earlier, amplitude is only pictured here in a quarter or 3/4 point, so notice there's 2 here. Our amplitude is 2 tangent of bx plus c. You'll notice also here that we have 3 different points listed. Negative pi over 6, 11 pi over 24, and this one over here is negative 7 pi over 12. I'm going to rewrite it over here since it's kind of cut off on our sheet here. So 7 pi over 12 is this asymptote line on this side right here. With 3 points, I have choices on which 2 I want to find the distance between. So I think I'll go ahead and go with 7 pi over 12 and subtract the negative pi over 6. So common denominators, minus a negative makes it a plus. That's 2 pi over 12, which is 9 pi over 12, which simplifies to be 3 pi over 4. The distance between my asymptote line here and this point is 3 pi over 4. I want to convert that to 1 period length. So from here, this is my right asymptote line. I go back to this asymptote line. That's 1 full period from here to here. And then from asymptote line back to the crossing is another half of a period. So I have a period and a half here, or 3 halves of a period. I want to solve for just what p is, so I'll multiply both sides by 2/3. That way here it cancels, and 2/3 here. And period length will be 2 pi over 4, or pi over 2. Now keep in mind, the period length for tangent and cotangent is pi divided by b, not 2 pi divided by b. So each of those are now equal to a period length, so they're equal to each other by substitution. Pi over 2 equals pi over b. Again, we can cross multiply, or in this case, because pi equals pi, 2 equals b, we found our b value to be 2. I want to plug that in up here, and we're 2/3 of the way done. Y equals 2 times the tangent of 2x plus c. Slide down here so I've got a little bit more room. Taking my argument 2, I'm going to put a value in for x plus c equals, and we're going to set it equal to something based on what value we choose here. Now there's no real right or wrong way to go here. Ideally, we're going to use the value closest to the x-axis, or closer to our origin right here, so that would be this number. We could use this one, or we could use this one. Either one, honestly, it does not matter, but we're going to use the one closest to the origin, or in this case, negative pi over 6. Now what I set it equal to is where does this point occur on the generic tangent curve. So I'm going to backtrack 2 pages to get to here. Here's our tangent curve. Notice we're coming through the x-axis here at the origin. So I'm going to set my argument equal to 0 because we're coming up through the x-axis. That occurs at the generic period there, or generic point at the origin of 0. Over here I'll do a little simplifying, 1 and a 3 when I multiply those together. So I'll add pi over 3 to both sides, and c will equal 0 plus pi over 3, or pi over 3. And we now have our equation for tangent. Y equals 2 tangent of 2x plus pi over 3. So going back up here, I'm going to get rid of some of this drawing. We're also going to find a cotangent curve, because we can find 2. The difference, however, is with tangent and cotangent, those graphs are reflections of each other, so our cotangent is going to have a negative amplitude compared to the tangent. So y equals negative 2 times the cotangent of 2x plus c. Different c value because our graphs are different left, right asymptote lines, different quarter, 3/4, and midpoints. So I take my argument, I'll use the same x value, solving for c. Going back 2 pages, I'm looking where it goes through the x-axis at. So going back 2 pages, cotangent goes through the x-axis here at pi over 2, which means I'll go back here and set my argument equal to pi over 2. So again, this is pi over 3, so I'm going to add pi over 3 to both sides. In order to add my fractions here, I need a common denominator, so I'm going to rewrite those with a common denominator of 6. This would be 3 pi over 6, this would be 2 pi over 6, so c is 5 pi over 6. So in my argument back here, I'm going to put 5 pi over 6 in for C, and there is our cotangent function. So two functions of each one. We've got one more here to hopefully make sure we're crystal clear on what's going on. We have what appears to be either a sine or a cosine curve. Now, just to make life simple for now, I would strongly suggest that we stay with a positive amplitude all the time. If you want to feel like you're a little bit more advanced, by all means, go ahead and attempt a negative amplitude. But I'm going to pretend this graph is basically starting here, and this is our full period right here. So it's a positive amplitude. If we start with a sine curve, it's going up to 3 and down to -3. So I'm going to do 3 times the sine of bx plus c. Okay, so to find our b value, we've kind of outlined that into a 3-step process. The first step is to find the distance between 2 points on the x-axis. The only 2 points we know are these two, so I'm going to subtract those two. 5 pi over 4 minus 3 pi over 4 is 2 pi over 4, or pi over 2. The distance then, we found the distance from here to here. I'm going to backtrack to our generic curve. We found the distance from here to here, which I hope we would all agree is a half of a period. So, setting up that equation, 1/2 of a period equals that distance of pi over 2. I'll multiply both sides by 2 so I can find out what 1 full period is. 1 full period is pi. In a generic sense, in terms of b, 2 pi divided by b, so we're going to set that equal to pi over 1 by making this substitution here. We'll cross multiply. Pi times b equals 2 pi times 1, divide by pi, and b equals 2. So we found our b value up here to be 2. And now we have to find our x value. So I'm going to take my argument, 2, leave my blank for the x I'm going to substitute in, set that equal to something, and solve for c. So again, we have these two different values we can choose for our x. Ideally, we go with one closest to 0, so I'm going to use 3 pi over 4. That point is coming down through the x-axis. Just to make sure we're crystal clear, I'll go back here. Sine is coming down through the x-axis at pi, so I'm going to set my argument equal to pi. If I cancel before I subtract, this is a 1, this is a 2. I'm going to subtract 3 pi over 2 from both sides. Oops, let's try that again. Subtract 3 pi over 2 from both sides, and that will give me c to equal negative pi over 2. I'll make that substitution into my equation, and oops, let's make it a minus, plus a negative is a minus. So minus pi over 2 is my equation for a sine curve. We've said that can also be a cosine curve. Now the good news is with cosine we have the same amplitude, the same period length, just a different c value. We can use the same information, 2 times 3 pi over 4 plus c. We do set equal to something different, so notice that we're coming down through the x-axis here. Back to our cosine curve, it's coming down through the x-axis at pi over 2. So I'm going to set my argument here equal to pi over 2 and solve. Then the same canceling thing here, the 2 and the 4 will cancel, so I'm subtracting 3 pi over 2 from both sides. And when I subtract 3 pi over 2, c equals negative pi, and I'll plug that into my equation, and we'll have our cosine curve as well. I don't know why I wrote sine here. Fix that at the same time I fix this, minus pi. That was kind of bad, so I'm going to try that one more time. Minus pi. And there's the equation of our cosine curve. Okay, so there's finally the equations based on the picture of a graph.